Hello, welcome to this video. This is 4-1 of the Essentials of Calculus, and in this video we are going to talk about the absolute extrema and the mean value theorem. Mean value theorem we'll actually get to in the next video. This video will just deal with the extrema, the maxes and the mins. So let's go ahead and look at some terms. Now here are some definitions, and these are just informal definitions. Please feel free to pause the video and cover these terms: absolute max, absolute min, relative max, relative min, and extrema, okay? And also critical numbers. So go ahead, pause the video, give those a read, okay? And then here is the procedure for finding the absolute or global extrema. Okay, you have to look at a couple of things. You have to look at the critical numbers from the function, okay, and we'll talk about how to do that. And then you have to find the y values at each critical number and each endpoint. So you'll see behind me right about here, I have extrema. You need to find the critical numbers and the endpoints. Very, very important. You look at both of those, okay, and then you'll just choose, okay, what is the biggest and the smallest y values or outputs, okay? So note, absolute extrema can occur at either the critical numbers or the endpoints. Relative extrema only occur at critical numbers, okay? So you don't have to consider the endpoints for relative maxes and mins. All right? All right, so what we're going to do here is we will look at some visual examples. And here it says, use the figure y equals f of x to the right to answer these questions. Question number 1, what is the absolute max of f? Well, I mean, if we look at this, you can tell. Let me get my pen out. Okay, here we go. You can tell that right here that the function, that's the absolute max of it. It's the tallest point, okay? And that occurs here for an x value is -4, and the output is 4. So when they say the absolute maximum of f, they want the largest y value of f, okay? So you're going to say here 4, okay? That is the absolute value the absolute max of f. Okay, question 2. At what x value does f have an absolute maximum? Well, we just identified that point, and that occurs at x equals -4. Okay, easy enough. Question 3, what is the absolute maximum point on f? Okay, so they want a point, so we just write it as an ordered pair, -4, 4. All right, easy enough. Number 4, what is the absolute minimum of f? Okay, so now I want the minimum. So I'll go ahead and look. I have values lower here, lower. And when I get to that lowest point, notice it's an empty hole. So what that's going to mean is we're going to say does not have one. Does not have one. Okay, so no absolute minimum on f, or there is none. Number 5, what x values does f have a relative minimum? Okay, so we're going to go ahead and look for relative minimums. Well, here's a relative minimum, right? All the values around it it's the lower than all the other values around it. Okay, then another relative minimum here is going to be at 1. Okay, I have a relative minimum there. And then notice at 2 how this point comes down. Well, at this point at 2, aren't all the values around it, right? As you come from the left of 2 and from the right of 2, all those values are bigger. So this is, by definition, a relative minimum. Okay, so says what x values? So x equals -3, 1, and 2. Okay. Number 6, at what x values does f have a relative maximum? Okay, so same idea. And then here I have a relative maximum right here. Okay, at x equals -1. And then let's go ahead and investigate. Are there any other points? Well, here this looks like a maximum, but again, it's an empty circle, so there is none there. And that's it. All right, so that is absolute and relative maxes and mins, okay? So moving on to the next page. Number 7 says, find the global extrema of f of x on the interval -1, 3. Okay, so for these problems, what you're gonna need to do is you need to analyze two things for global extrema. You can have an extrema at, again, your critical numbers, as well as the endpoints. Okay, so what are the critical numbers? Well, what we're going to do is I want to go ahead and find out when is the derivative 0. That's going to be a critical number. So what we do is we are going to take f prime of x, and if I take f prime of x, we get x squared minus 4x. Okay, and I just set this equal to 0. So I have x times x minus 4, and I set it equal to 0. So x times x minus 4 equal to 0 gives us x equals 0, or x is equal to 4. So here are my critical numbers, and it's important to note that the interval is -1 to 3. So note how 4 is outside of that interval. So what do? Throw it out. Okay, so it's no longer a critical number. Okay, so I want the global extrema. So what we're going to do here is go ahead and plug in our critical numbers and our endpoints. Okay, so I'm going to test my endpoints. So what is f of -1? Okay, so when I plug in -1, we get an outpoint. This output, this becomes -1/3 minus -1 squared is 1 times 2 is 2, so minus 2. So we get -2 1/3. Okay, then I'll plug in my critical number, f of 0, and we get 0. Then we'll plug in f of 3. Okay, and this will give us 3 cubed is 27, divided by 3 is 9, minus 3 squared, that would be 18, to give us -9. Okay, so where is our global and absolute extrema? Well, I have a max. The highest value occurs here. Okay, and what is my lowest value? Well, that occurs here. Okay, so the max is at f of 0, which is equal to 0, and the min is at f of 3, which is equal to -9. Okay, and there is your answer. All right. Another thing too about critical numbers, it's important to note, I'm gonna jump back up here, that critical numbers are at x values, which f of x exists, but f prime of x is either 0 or undefined. So I covered the 0, I didn't cover the undefined in this case. Note that our function f prime of x, it's there's no undefined values, so we don't have to worry about that for this example. Okay, on example 8 and 9, there may be an example of that. Okay, all right, so number 8, find the absolute max and min values of f of x equals the absolute value of x minus 2 on the interval 0 to 5. Okay, so what we're going to do is, it's important to note how this function this function kind of looks. So I'm going to sketch this. 1, 2. And this function looks like this. Okay. All right. So looking at this, a critical number that we have, which I'll abbreviate Cn, occurs right here at x equals 2. Okay, and the reason is this is a sharp turn. So what we have here is f prime of x is undefined. Okay, I don't have a derivative for that. So that is a critical value, okay? Notice for the rest of the function, absolute value functions, there's no derivatives that equals 0. So we don't have to worry about those, but we do have a point of non-differentiability, okay? So what we're going to do is, again, evaluate our function. I have the interval 0 to 5, so I say, okay, what is f of 0? And then I plug that in. That's the absolute value of -2, which is 2. Then I do the same thing for my critical value, 2. Well, when I plug in 2, that's the absolute value of 0, which gives me 0. And then we'll do the same thing for f of 5. We plug that in. That's the absolute value of 3, which gives us 3. Okay, so therefore, our max occurs when f of 5 is equal to 3, and our min occurs when f of 0 is 0. Okay, and again, that's on that interval 0 to 5. All right, last example here. Find the extrema of f of x on -1 to 3. Okay, so again, what we're going to do is we are going to find our critical numbers. Okay, and what we'll do is I will take the derivative of f of x. Okay, so what we get after using the power rule here is 2x to the power of -1/3 minus 2. Now I'll rewrite this. This is 2 over the cubic root of x minus 2. Okay? So what we want to do is a couple of things. I want to set this equal to 0. So I'm going to set it equal to 0. This gives us 2 is equal to 2 divided by the cubic root of x. Okay, I'll multiply both sides by the cubic root of x. Okay, and so I'll just come up here. We get 2 times the cubic root of x is equal to 2, which after dividing both sides by 2, we get the cubic root of x is equal to 1. Cube both sides, and you get x is equal to 1. Okay, so there's one critical value. The other type of critical values, right, you set it equal to 0, or you say, okay, where is my function undefined? And, if we look at this example, right, when you're talking about rational expressions or equations or functions, you can't have a denominator 0. So we say, okay, what value will make that denominator 0? And then therefore it's undefined there. Okay, so we can say f prime of x is undefined at 0. Okay, at x equals 0. I'll just put that for you guys. Okay, so what we did, we found two critical values. I found x is equal to 1, and I found x is equal to 0. And of course, what I want to do is I want to determine the extrema. So I'm going to plug these values in along with the endpoints. So critical numbers and endpoints. Okay, so I'll kind of color code for you. So here, f of -1, I'll plug in -1, and what we get is 3 times -1 squared is 1. Take the cubic root of that, that's still 1. Minus 2 times -1, so that's plus 2, and we get 5. Okay, f of 0, this is a critical number. So I'll put it in red for you, f of 0. And when we plug in 0, we get 0. We'll also test f of 1. Plug in f of 1, and we get 3 minus 2, which is 1. And then we'll test our endpoint, which is 3. So f of 3. Okay, we plug this in, and we get 3 times the cubic root of 9 minus 6. Okay, and notice the cubic root of 8 is 2. So this is just slightly larger than 1. Okay, so just know it's approximately 1.2. Okay, I believe. Now I feel like I should definitely investigate. Let me check this. No, sorry, it's 0.240. Okay, so and then we'll decide. Okay, what are our maxes? What are our mins at these values? Okay, so it looks like we have a max at f of -1, which is 5, and we have a min at 0. Okay. All right, that does it for this video. In this video, we talked about Extrema, the absolute extrema or global extrema, and then we also talked about relative maxes and mins. All right, watch the next video. We're going to talk about the mean value theorem. Catch you next time. Peace.